Right, so hello again. So this talk is all about integration testing web APIs in ASP.NET Core with a little help from Docker. So I want to start off by just a little tiny bit of a journey I went through last year with TDD. So I've been developing for quite a long time, and I've always tried to write testable code, like, using solid principles, dependency injection, this kind of thing. But it's just so happened that I hadn't actually worked for a company that does proper TDD up until last year. And the project I was working on last year did TDD properly full time. So I thought I wanted to talk a little bit about that journey. And given that I'd previously done testing, I'd used mocking libraries, I'd used XUnit and all this kind of stuff, I didn't really have a big technical learning curve as far as doing this. It was more just observations as we went across. And my initial thoughts were, whoa, we're spending so much time, like more than 90% of our time writing tests. This feature I could have written in an hour, but we're spending days on it. And it wasn't just me being new to TDD, this was just everyone. But then my next observation was that I really started to see the benefits. We had hardly any bugs. It was so different to other code bases I've worked on, where you have a massive buildup of bugs to fix at the end. We could also refactor more safely, and the test would catch most things. But so it made a really big difference, but at what cost? It just took so long to write. We could refactor safely, but refactoring took ages too, because we had to refactor all the unit tests too. But we didn't just write unit tests, we also wrote integration tests, ASP.NET Core integration tests. We used Docker to spin up real databases to test against. And one thing I observed was that a lot of the time, the integration tests would render a lot of the unit tests redundant. And that's the main takeaway I want to take away from this talk. Especially for web APIs, I would recommend, because it will save you a lot of time, favoring integration tests over unit tests. So if you think about like a typical, if you picture this being like a request going in and a response going out, and this is just touching the surface with some of the stuff that happens. So with a web API, you've got to deal with routing, authentication, authorization, binding and validation, middleware. So you might have a bunch of your own middleware classes, your data access layers. You might use the repository button. You might use an ORM like Entity Framework or Dapper, and business logic. So we've got all these different classes. Do we need to unit test each of these and then mock out everything else except for the thing you're unit testing? Because these are like classes, they're kind of implementation detail, each of these classes, where actually the business requirement is that when we make a request in, say, for example, we're creating an order, we're sending a post request, we get a created response back, and the database has been updated with what we expect. And this database doesn't have to be SQL Server. It could be anything MongoDB, InfluxDB, message queue. It could be RabbitMQ. Generally, a web API does talk to some database or some external service. And that's enough of the slides because we don't like slides. So I'm going to jump over to Rider. So I'm doing this demo in Rider, but the same applies if you're using Visual Studio, VS Code, the command line, whatever. So I'm creating a web API project. I've called it Integration Test Talk, because why not? And that's it. So I'm just going to create this. So I've got a brand new project. And it's out of the scope of this talk to explain a web API project, but basically your startup has configurations, so you can set up your dependency injection registrations, you can set up various stuff, middleware, and basically bootstrap, set up the bootstrap. You'd have controllers, which are your API endpoints. So you've got a controller, which is like a class effectively, and you've got methods called actions, which is the entry point into when you call an API endpoint. So we're going to create a new endpoint at the moment, but because we're good citizens, we're going to create a new project. So we're going to create a unit test project and just call it tests. Ooh. Oh, sorry. I failed at the first here. Let me just delete this. I chose NUnit instead of XUnit. That wasn't very good. delete this. Project already exists. Test 2. That's not very good, is it? Right. So to create an integration test, you've got to add a NuGet package. So I'm going to do this using the NuGet package manager in Rider. It's the same in Visual Studio. It's just a different UI. And if you search for MVC testing, you will get this package. So we're going to install this now into the test project. And whilst I'm here, I'm also going to install another library called Fluent Assertions, which I will show in a sec, but it's really good for asserts. So now we're good to go. We can write integration tests. And by adding that package, there's something called a web application factory. This one. And basically, I'm going to change the way this works, but at the moment for this example, I'm going to new this up directly. And this takes a generic type, which can be basically any type in your web assembly, but most people tend to use the startup. So if I put startup in here, or if I type, and I'm going to use the tooling to reference the web project from the test project, just so I've got access to that. And then when you do this, you've got the methods in here. There's 2 here: create client, create default clients, which both return HTTP client. Now this is the HTTP client that we all know and use if you're making outgoing HTTP requests. So we get one of these, and the create default client, create client is a bit adds a bit more functionality. It does handles redirects and cookies, but we don't need that, so we'll do the default client, and we can just return that. So running this will actually spin up an in-memory version of your web API and return an HTTP client for you to access, which is really powerful. So we can just do client.get, you can do post, put, patch, and we're going to add a new endpoint called podcast. So if we just await this, and then return a response. And then we can assert on this. So this is where that library added is. So what we want to do, we want to do a GET request and assert that this status code is okay. So we can do that. And now this should be syntax is basically that Fluent Assertions. Fluent Assertions adds lots of different extension methods to make your assertions really fluent, and there's lots of functionality for comparing different object types. It's really, really powerful. Okay, so if we run this test now, as expected, we're doing TDD, so we've not actually written an endpoint yet, so we've got a failing test. So now we can implement that endpoint. So we can say its status code was okay, but was expected okay, but was not found. So if we just take this endpoint now, this is the endpoint which was created when we created the new project. So we don't need all of this. We don't need what's in here. And to satisfy this test, we're just going to say return okay. And then just change the return type. That can be by action result instead. Get rid of all these. So now we've got a really clean endpoint. In fact, that's still going to fail because for those that don't know, this root, when you've got the syntax with the square brackets for controller, that just means that it's going to get the endpoint, the path of the endpoint from the controller name. I need to rename this to podcast to match the endpoint in our test. So now, hopefully, if I run this test again, it should now pass. So you can see that within just 4 lines, we've quite easily done an integration test. If I just rename this to something like given get request to plug to when people are watching, return okay, whatever we want to call that test. So this is all fine and great, but most endpoints don't just return okay. They do more stuff. They would talk to a database or something. So this is where Docker comes in. So in our test project, if we just create a new file called docker-compose.yaml, and I'm just going to paste a snippet in here. So talking about Docker is kind of out of the scope of this talk, because it's only a lightning talk. But basically, if I run a command on the command line, which I'll do in a sec, called docker compose up, in the same directory as this file exists, then see this image here. It's going to look on something called Docker Hub. So this is a remote image repository for this image name. And this is SQL Server, but there's, I don't know how many images in Docker Hub. You've got things for MongoDB, Postgres, MySQL, anything you can think of. And it will pull the image down. If it doesn't already exist, it will cache it if it already exists. And it will spin up a container. So think of a very super light VM running SQL Server effectively. But just by having this. So if we go to the command line now, if I just go to this new project, and I've got to remember to go to because of the mistake I made before. So this is the directory of Docker Compose. So if I do Docker Compose up now, this is now spinning up SQL Server. So this shows how powerful Docker is just by doing that. SQL Server is now running. And I can tear it down as well and just start again. It's really, really powerful. Normally in your project, you'd have something to handle, scripts to handle creating the database, doing migrations as you make changes to your database schema. And let's say it might be entity framework migrations. You might use there's various projects. Flyway is one of them. There's a few different ones. Or you might just use raw SQL scripts. But either way, that's out of the scope of this talk. So I'm just going to do this manually in this database we've just created. I'm basically going to say create database DNO lightning talk and run this. Then what I'm going to do is create a table called podcast with just one column in saying name. So again, I'm doing it manually now, but you'd normally script this and you'd be able to run your migration scripts as part of this Docker file. So if you do docker compose up, it would create the database, it would create the tables and run whatever seed scripts you might have. But again, I'm wary about showing too much stuff in the lightning talk. So that's now good. So if we just create a brand new test in here now, and again, I'm going to copy a snippet now. Just to save time. So ignore this bottom line at the moment. So this bit is a duplication of this bit, and we'll remove this duplication a bit later. Then here, I'm basically saying, create me a string and it's called Unhandled Exception Podcast. I've never heard of this podcast before, but if you go to your favorite podcast app, search for it and click subscribe, good things might happen, I don't know. And I'm adding a GUID, just a random GUID at the end, so that basically each test is unique, so they're not conflicting with each other. And then I'm using the client and so to our in-memory server, sending a post request with that podcast name. So I'm basically saying, I'm doing a post request to our endpoint and saying that, yeah, create me a podcast in the database. And then, so this is kind of like the kind of arrange, act, and then assert kind of stage. Then I'm asserting that created has been returned. And then this bit, so if we just go back to the slides a sec. So if you remember this bit now, because this database we've spun up specifically for our tests, and so our tests are running at this level here, there's no reason at all why the tests can't directly talk to the database to add test seed data or to assert that a request has done what it's expected. So we're just going to do this. So this test database helper, we're going to create a new type, shove that in its own. Sometimes rider alt enter just stops working, and I don't know why. Let's do it here then. Move this to a new class. And then again, on save time, I'm just going to copy a snippet. So let's delete that. Add a few missing dependencies. So basically, this is just saying effectively from the database, select all the podcasts where the name is what I pass in to this. And if we go back to the test, we're saying that we're getting podcast by name, which is this, which is this, which is what we passed in our post request. And we're saying it should exist effectively. SQL connection, I need to add a NuGet package for that. So let's just find this on NuGet. So that's system data client. Install this. And then I'm also using Dapper to do this request. So again, if we just search for Dapper here, install that. Cool. So now, and notice that I'm hard coding a connection string. That's fine because this is just a temporary password which we specify in the Docker file here. So it's not your password or connection string that we're using in production or any deployed site. It's just a password for the tests. So in this case, it's fine to hard code the connection string. And yes, I'm just you can picture having a whole bunch of helper methods just for the tests to get specific stuff from the database to assert that the tests are doing what they should be doing. So if we run all the tests now, and you see the name given post request to podcast endpoint, the new podcast record should exist in the database. And it's failing. And it's correctly failing because we haven't created that endpoint yet. So if we go back to our controllers, and again, I'm going to paste a snippet. And this is where everyone is going to tell me off. And I'm contradicting what I just said before, that if I put this in here, I am temporarily, just to keep this talk simple, hard coding the connection string to the same one. Obviously, it's going to be different in your production UAT environments. It's not going to be local host, so you're going to have to pass this in configuration anyway. But from security point of view, never do this. This is just to keep the example simple. So you don't want real connection strings in Git at all in any shape or form. But for this demo, I'm doing this. So I'm going to, again, add the NuGet package SQL client. I'm going to add Dapper. Oops. And then, so I should point out that normally you wouldn't have all this in your controller endpoint. You normally have multiple classes. You might have a data access layer. You might be using a repository path and entity framework. I'm just using Dapper here. But to keep this example simple, I'm just shoving this code into the controller. But you would normally have more stuff. But I want to, this talk isn't about writing endpoints. This talk is about the test side of things. So if we run all the tests again now, that's now passed. So we can see how really simple it is. I know I've copied a few snippets over, but I've pretty much started from scratch to knock up integration tests, which kind of, you can write tests to cover all these different scenarios. So you could, like validation, you could pass in invalid models. So you can do different things to test all these without actually unit testing each individual bit. So if we just go to our test now and do a bit of tidying up, because I mentioned earlier that we've got like duplications here and down here as well. So in XUnit, if you create a constructor, then that constructor will be called once before each test. So we can copy this lot into our constructor. We can make client a backing field. And then we can use that here. And then we can delete this duplication as well. And we can use that here. So if we run all the tests again, they're still passing, so that's good. So that's cleaned it up a bit more. One thing I just want to point out is that quite often, I mentioned startup before. So in the startup class, you set up all your IOC dependency injection registrations. Sometimes in a test, you might want to overwrite it or configure it slightly. Web Application Factory, you could do, and again, I'll tidy this up in a sec. You can override these, so we can do test services. So we can do this, and we can do services. And in the same way as you would set up a type services, in the same way as you would do IOC registrations like this in startup, you can override them in your tests. So for example, you might have something like this, which say you've got a stock service, which one of your endpoints is calling out to some other service, which you can't have your test running against. You could just replace this with like a fake, which is like returning hard-coded data, for example. Adam has actually got a talk next where he's going to talk about Just Eat's HTTP client inception library, which is an alternative way of doing this, which means that you don't have to mock out your implementation of iStock service. But we don't need this for this talk, so I'm going to comment that out. One final thing, I think or two final things. I mentioned before that this constructor is called once per test. And quite often, if you've got lots of different overrides or like you're changing what's happening in startup, like you're doing a few different setup stuff, then you don't want to repeat that for all your different tests. So instead of like newing up here, Web Application Factory, we can create our own custom class. Which basically inherits from Web Application Factory. And then we can override configure web host. And you can see that configure web host is taking a builder, just like we've got down here. So down here, we can get rid of this. Oops. And we can get that, and we can move this into our custom class now. And then we can move this custom class into its own file. So now we can reuse this. So we might have a whole bunch of extra configuration here. And we can, instead of newing up this, we can new up this. We can get rid of these usings, which aren't being used now. And if I run those now, this is all going to pass still. And one final change we're going to make before I finish off and hand over to Adam is that if the X unit has got something called iClass fixture. And what this does is that any type you specify in this generic, X unit will instantiate that for you once per this entire test file. So if I take this custom web application factory and pop that up there, I don't need to instantiate this here anymore. And to access this instance, all we do is inject that into the constructor. So I can do this. I can replace this for factory. And then I can run the tests again, and they all pass. And then this becomes really reusable across all your integration tests. And we have nice, super clean tests, which are testing quite a lot of functionality, because it's not only testing I've lost my, I've closed my slides accidentally, but it's not only testing all those things that we saw in the slide, like routing, authentication, authorization, and all this kind of stuff. It's testing your startup as well. So it's testing all of this stuff as well. So we're getting a lot of bang for buck for these tests. Cool. So I think I've overrun very, very slightly, but thank you for listening. And I'm now going to hand over to Adam Storr, who's going to be talking about Just Eat's HTTP client interception library.